So today in this video I would like to explain the work holding devices used in a shaper machine. Also the operations carried out normally on a shaper machine. The photo shows a shaper machine. As you know, I think from the previous video you have learned about the machine. This is the RAM which reciprocates, and this is the tool head, and there is a clapper box and a tool post where the tool is fitted on this tool post. And here you can see a vice is on the table of the machine, so the workpiece is fitted on the in the vice, and the cutting operation is this tool reciprocates, and the workpiece you can give the feed on the in the perpendicular direction of the cutting movement. The cutting motion is in this direction, and the tool movement or the feed is in the direction. By rotating the hand wheel here, you can move the table along the cross direction. So this is how the machining operation is carried out on a lathe. This can be clearly shown in the next figure. You can see this is the cutting tool and this is the workpiece. So the cutting tool reciprocates. So while reciprocating the cutting tool, we are giving the feed in this direction. This is the feed movement. So while both this direction of movement is possible to create a horizontal surface like this. Now we'll see the work holding devices. For every machine there are work holding devices for firmly holding the workpiece while doing the cutting operations. So here also you can see a vice can be used. Different types of vices are there. Then clamps and stoppings, T-bolts and step blocks, angle plate, V-block, and some special fixture can also be used. So the figure shows the plain vise. It's widely used not only in shaper machine, it can be used in other machines like milling machine, drilling machine, etc. So this vise consists of two jaws. One is fixed, this is fixed. The other one is mobile, and there is a screw, and there is a handle here. By rotating the handle, you can move the mobile jaws to and fro. So just keep the workpiece here, and after keeping the workpiece you can just tighten the screw, just to rotate the screw in the clockwise direction so that the mobile jaw will move towards the workpiece and it will be firmly held in between these two jaws. So this is how the vise is working. This is an angle vise. It's similar to the plain vise, only the thing is here we have a swivel base, which can be tilted. That means angle vise is a machine vise that can be tilt in the object while in operations. The main feature of the angle vise is the tilting of the white vise when the base remains stationary. So this is the base of the vise. This can be strongly clamped on the table of the machine, and after that you can tilt this base. This is the swivel base, so this can be turned like this. So now the inclination is up to here. So again, if you want to rise, you can rise, and up to 90 degrees possible. Vertical is also possible. So this is the how you can change the inclination of the vise with respect to the base or the table, and the workpiece is held in between this one. So this is normally used for if you want to have to machine an inclined surface. Suppose you want to cut the machine an inclined surface, or if you want to cut the cube, the vertical face of the cube to an inclined directions, this is possible. This can be used. Then another method is by using clamps and stops. So this is very simple. The workpiece is held or kept in between two, that means one is a stop pin and another one is the rectangular strip. This is the rectangular strip. Rectangular strip consists of a bolt, a bolt, T-bolt, and it is kept in the T slot of the table. This is the table of the machine. And after keeping this one, this is tightened, this nut is tightened. So just to keep the workpiece in between these two stop pin and the rectangular strip, then just to tighten the bolt of the stop pin. So when it is tightened, the workpiece will be pushed in these directions, and after that, as there is a stopper here, so the workpiece will be strongly held in between two these things. Another thing is by using T-bolts, clamp, and step blocks. These are three elements are there. One is the step block. Then this is the clamp, and this is the T-bolt. So together, both these together, we can hold the workpiece. This is the workpiece. So one end of the clamp is on the surface of the workpiece. Another end is on the step of the step block. So based on the height of the workpiece, we can keep in any of the steps. And after keeping this one, after making it flat, means the horizontal, this clamp, then you can just tighten by tightening the nut. And the fourth one is the angle plate. Angle plate is also widely used in all the different types of machines. Angle plate is nothing but it is an L-shaped plate, and it is having slots on both the horizontal surface and vertical surface. This the slots on the horizontal surface is to hold the angle plate on the machine table or machine belt, and these slots are for holding the workpiece. So workpiece can be held here, and by using T-bolt you can tighten this one on the vertical surface of the angle plate. Then the V-block. V-block is also widely used in all machines. Here the V-block is used for holding the cylindrical workpiece, and if you want to make a slot or a keyway on the cylindrical workpiece, this is the position. That means the job is placed on the V-block, and V-blocks, we are not clamping the V-block, but instead of clamping the V-block, we have two or four bolts on both sides of the V-block, and just insert a clamp after keeping the job on the V-block. Just insert the clamp and just tighten the nut of the bolts after inserting this clamp, so that it will firmly hold the job in between the V-block and the clamp. Okay. Then the shaper operations. So for obtaining different shape surfaces, either vertical or horizontal or inclined surfaces, we can use this shaper machines. This is not used for making the cylindrical surface, because here all movements, the feed movement, the cutting movement, etc., all are translatory movement. There is no rotation. This machine doesn't have any rotary movement. All are translatory movement. So this is used for generating flat surfaces. So sometimes we can generate conical surface like concave, convex, etc. But it is not widely used because the accuracy of machining comparatively less. You can make it, but not normally used. So making slots, grooves, and keyways, and producing contour, concave, and convex surface. These are the different surfaces which can be generated on a shaper machine. So the figure, the schematic sketch shows how the horizontal, vertical, and inclined surface are generated. So here, this is the cutting tool and this is the workpiece. So this is the feed movement, and this is the cutting movement. So this two picture shows the two movements of the cutting tool. That means the cutting tool reciprocates this cutting motion. At the same time, you are giving the feed to the table, so that the workpiece moves in the perpendicular direction to the cutting motion, so that we can have a horizontal surface. Similarly, the vertical surface, the difference is we are giving feed on the vertical slide of the tool head, which is on the ramp. So tool head, you can see at the top of the tool head there is a wheel. When you rotate that wheel, that tool, the vertical slide moves up and down. That means by rotating that wheel you can give the vertical feed. So the feed movement is perpendicular, that is vertical, and there is no movement for the table. So you are not giving feed to the table while doing the vertical surface, machining the vertical surface. Similarly, the inclined surface can be generated by tilting the vertical slide of the tool head. By tilting the vertical slide of the tool head and give the feed by rotating the screw of the vertical slide, you can have inclined machine. Inclined machining is also possible. Okay. So this can be clearly understand by using this figure. So here this is the front view of the machine. That means the tool head, this is the tool head, and this is the vertical slide, this is the vertical slide, and this is the apron. So the end of the bottom of the apron, there is a clapper box and a tool post where our tool is held. Now this is the workpiece on the table. Now for getting a horizontal surface, the tool is reciprocating. At the same time, you can give the feed in the perpendicular direction by moving the table, so that you can generate a horizontal surface. Now you can see how the vertical surface is generated. Here this is the vertical slide. So here for this vertical machining, uh, we have tilted the apron a certain angle. This is not for functional purpose. It is actually for getting a good clearance between the workpiece and the tool post. Otherwise, there is a chance of hitting the tool post or the workpiece while doing the machining operations. So for getting a clearance, this is better way of just to tilt the apron. We are not tilting the cross, the vertical slide, and just give the feed by rotating the wheel, so that the tool will be moving along this vertical feed, vertical slide, so that the tool will be tracing the same path. That means you can generate a horizontal, a vertical surface here. Now we will see how the inclined surface is generated. Inclined surface can be generated with two ways are there. The first method is by using an inclined vise, an angle vise. As I told you before, that means you can keep the workpiece in an inclined manner and you can have a machining operations. But another method is by tilting the the vertical slide of the tool head. So this is the vertical slide. Just swivel that one. There is a swivel base is there, and there is a angle is marked here. So the required angle can be tilted or swivel this one. So after swiveling this, just tighten this vertical slide so that it will not change the position. Then you can give the feed by rotating this the screw of the vertical slide, so that the tool will be, that means the entire apron or toolbox, everything will be moving along the axis of the vertical slide. That means this axis. So this axis is not perpendicular, it is inclined with the perpendicular axis. So because we have inclined this vertical slide, so the same angle inclination will be tracing by the tool also, so you'll be getting the same angle. So whatever be the angle of the vertical slide, the same angle you can generate here also for this surface. So this is the method of generating inclined surface. This is the method of machining keyways or slots on a cylindrical surface. Just to keep the surface or the cylindrical object here on a vise, and it is stationary. The vise is stationary. Now we are giving the cutting motion, that means reciprocating movement of the cutting tool. This is the tool specially used for making slots or keyways. This is for machining a concave or convex surface. Here, the cutting tool has to have two types of movements. That means the to vertical feed as well as the horizontal feed is required. That means horizontal feed we are giving by moving the table, and the vertical feed we are giving by rotating the vertical slide of the tool head. So both has to be done simultaneously for getting a contour like this. So this is something difficult, and the accuracy may not be good. So normally it is not done in a shaper machine. So we can generate the surface by simultaneous movement of the vertical feed and a horizontal feed. Now we will see the cutting tool materials. So as the tool used in the lathe, here also we are using a single point cutting tool, and the cutting tool material should be very hard material compared to the workpiece material. And normally used cutting tool materials are high carbon steel, high speed steel, carbide tips tool, stanlite tool, and diamond tool, etc. Different shapes of cutting tools are these are the common shapes. That means round nose tool. Round nose tool is having a nose radius. That means the tip of the cutting tool is not sharp, it is rounded. It is rounded. This is for normally used for rough surface, for generating rough surface. That for the depth of cut as well as the feed will be larger, comparatively larger. So if the cutting edge is very sharp, the chance of breaking the tip is high. So normally this is used, this type of tool is used. So the tool life can be increased, but the surface finish will not be much better. It will be comparatively less. Similarly, the right hand inclined and the left hand inclined tool is also used for roughing operations. Then the finishing tool, this is the finishing tool. Here is flat surface. You can see the cutting edge is flat, and this the metal removal rate is comparatively less, but it is better to have a good surface. The surface finish will be comparatively better. And this is for cutting T-slots, side recessing tool or T-slot tool. Here the tool shape is also L-shaped tool, so that the cutting edge can go into the vertical surface of the T-slot. Another one is slot cutting tool. Slot cutting tool is the based on the profile of the slot required, you can have the same profile or the same replica on the cutting tool, and just cutting tool you are reciprocating, you are not moving the workpiece is stationary. Here workpiece is stationary, and you are just reciprocating the cutting tool, so to and fro by using the ram movement. And another one is a gooseneck cutting tool. Gooseneck cutting tool is having gooseneck shape, and because of that shape, a cushioning effect will be there while doing the machining. By hitting the surface of the workpiece, there is a cushioning effect that is can slightly bend, so that the machined surface will be comparatively better surface. That means better smoothness will be there. But it is not widely used for machining. It's only for finishing operations, not for roughing operations. So the metal removal rate is very low. Okay. So these are all about the tool work holding devices used in a shaper machine.